Yeah, because HCC is a very insidious disease. The mortality rate is very high when it was called late stages. But in the early stages, like within the stage 1, 2, in the clinical stage, and particularly those cases within Milan criteria, which just means where it's eligible for liver transplant. And the cure rate is very high, means like almost 90%. And but however, most of the guys come to the attention of the condition is very late. Means because the disease is very insidious. They don't have a lot of symptoms. Basically the people have long time carry up the hepatitis and alcoholics and have cirrhosis. They didn't realize it until the early stages, and then when they come to there, and then the tumor become quite large, and some of them actually multiple nodules and just not operable. So in that case, the survival time in 2 years, I think probably less than 20%. So in that case, if we catch the disease early, it's curable. But if you catch late, they're almost certain death. So this area, I think that's the reason we can improve the efficiency of the diagnostic tool. Currently, the most convenient tool to screen the HCC is AFP, means the alpha-fetoprotein in the serum level. But that's not very sensitive. It could a very high level, and then able to see maybe that's it. Another way to deal with it actually is to, if we're a high risk individual, then you basically have a every 6 months, every year have a MRI, ultrasound things. A little bit expensive. Now ultrasound is not very sensitive. MRI, yes, but it would be quite expensive and very you require a lot of resource to do that. So why don't we just find some screening tool that able to efficiently, basically, we take about maybe approximately 3-4 drops of blood from a patient, and I'm going to tell you that you likely have HCC or not. I think that really helpful. So I think that's the main point of our paper. Yeah, because actually those fusion transcript actually is from the tumor cells. I mean, this fusion transcript would not be present in the physiological condition. It means that you and me and anybody, if they're healthy, they have no cancer, it should not should not have any of these things exist in the cells. Now, it means that if first actually is because of the chromosome combination, means that the genome in the cancer genome basically recombine each other and cause the splicing of the different genes that are together produce so-called chimera type of mRNA we call fusion, and then produce someone like produce a chimera protein that actually has oncogenic, and 3 of those in the study actually are oncogenic. The other one is more like a passenger fusion, means fusion genes. So those cells, when the cancer cells actually interesting, they're not resting in one place. They always threaded to the blood, and then go to the blood when they travel in the blood, and then get threaded out too, imported by the violent flow of the blood cells and things like that. It broken up, and then those mRNA get released. So actually, you can see them very easily. So in that case, basically, I get a tiny snip of the juncture area of the fusion gene, about maybe 60 to 80 base pair, teeny bit, little bit in RNA form, and then we basically using a primer on both ends of this snippet, and then with a little probe in the center, right at the juncture of the fusion point, and then we do a so-called TACMan, RT-PCR, the C detected. So actually very sensitive. We could, I think, means we could able to detect like maybe 30-40 copies, means even less in the serum sample. So when we see them actually, okay, the patient when they are cancer and then they become positive, and then after the treatment, and you see those fusion gene transcript quantity go down in the blood too. Basically, you see this guy looks like have a remission, something like that. And then if they come back, they also show up first in the serum. So we could detect that, okay, they're coming back. You need to do something. I believe that actually even before they see in the imaging, we already detect them in the blood. So that's actually really helpful. So for this, I think this is a sensitive methods to able to detect and supervise and actually assess the impact of the treatments and progression and things like that. So it's basically with a recurrent test and follow up on the patient for all his life once they have cancer like this. Yeah.